Okay, so here's another function we're going to work out the partial derivatives for. We've got f of x y equals e to the power of x times cosine y. So when we go ahead and work out df dx, all we got to do is differentiate e to the x because cosine y is just a constant, right? When we differentiate this thing with respect to x, cosine y is a constant, so cosine y is a constant. All this just looks like is constant times e to the x. And so the first derivative of this function is just this function itself. And indeed, all of the derivatives with respect to x are just this function itself. With respect to y, however, e to the x is a constant, so then we've just got to differentiate cosine y. That goes to minus sine. Then you can go and do the second derivative with respect to y. That's going to go to minus e to the x cos y. Again, you're just differentiating sine of y. So all of the second derivatives with respect to y, or all the even derivatives, second, fourth, and so on, that's just going to be that's just going to pick up a minus sign each time it goes through that cycle. And obviously, you can see a relation between the mixed derivatives. So, for example, right, this function's, you can swap the mixed derivatives comfortably. So it's like differentiating this with respect to y. It's just going to be it's just going to be that, right? So I took df dx. I should write. I did it in this order. Not that it matters. I took this and differentiated with respect to y. So yeah, that's a pretty easy function to find the partial derivatives of.